Hello everyone. In this video, we are going to discuss the connectivity of a 3D model and present a new interface of an existing function in Luban software. Let's open Luban and then open a 3D model. The 3D model is in STL format and it has two sphere components in the STL. Obviously, these two spheres are disconnected. What about the second STL file? This is the first STL file, and that's the second STL file. Do you think they are connected or disconnected? If you only look at the spatial relationship of the two spheres, you might say they are connected. But in terms of 3D modeling, these two spheres are most likely disconnected. Here, disconnected means they are not connected at triangle level. In Luban, you can enable the display of the edge to see a model and disable the surface. The two spheres do intersect in space, but there is no overlapping edge between the two. There is no overlapping surfaces as well. And in STL, all the surfaces are triangles. And the edge is each edge is supposed to be shared between two faces. And this is called two manifold 3D model. So they are disconnected. These are just two simple examples to show you the connectivity of 3D models. If you can see that some components are disconnected, then obviously they are disconnected. But some of the model may contain components that intersect in space. However, they are still considered disconnected components. Luban has a function, convenient function. Mesh and the mesh separate, it is called separate, to help you separate disconnected components and save each component as an individual STL. This function used only to do component saving without a very straightforward interface. In the new update, if you click separate and then select a folder to receive the individual STL, Luban not only saves the components in the folder, but also labels the component in different color in the new window. And here you can clearly see that they are disconnected components. One is in yellow, the other is in red. And there are visualization tools that you can use under the object menu. The first is the select tool. Keyboard shortcut is J. So if I press J, I can use a slider on the toolbar to highlight the component. I press J again, it will exit from the select tool. The other one is explode tool. You can press keyboard shortcut E or R to explode or restore the view. So if you press E, you can see these two components moving away from each other. If you press R, they will go together. This is basically the main usage of mesh separate function. This function can help us do initial analysis of STLs. For instance, some of the hidden error of STL is not that obvious if you open the file, but they can be easily seen if you use a separate tool. I'll close the content of the window and then load some existing examples. I have downloaded several Pokemon models, and these models have many defects. For instance, The one that I like to I usually use as an example is a dragon model. When you just look at it, there might be something wrong here, and you don't know if there are other things that goes wrong. Click Mesh Separate and go to the export folder. You can select any folder. I just happen to use the new folder on my desktop. And you see many components. And if you use the Explode tool, you can see that some of the components don't even have a closed surface. So these are obviously considered as defects in a mesh. If you cut such a mesh, you will get many errors. Okay. And then we can look at other examples. I will go to my STL collection. For instance, this is a alien model that many users might have downloaded from the internet. Go to Mesh Separate. This model is big, so it takes a little while to process. The separate function shows that the model has several components. I'll use the select tool. The first component, second one, third, and then the rest are the limbs. Now you can easily see that these are the components of an STL, while the original one is seemingly all connected in one body, which is actually not. I will show another example that has defects. So how do we tell if an STL has defect? I think I have a duck. I can't remember the file name, so let's load all of them. Okay, I'll quickly use this one as an example. Mesh Separate. If a model indeed has only one body, there is no disconnected component, you will see this message. Only one mesh object found, which means the mesh is quite likely to be a good mesh. The one that I wanted to show you is, okay, this one. If we check the mesh separate, okay, before I check this model, I'll go to the export folder and delete all the previous exported part files. Then we go to mesh separate and select the export folder. On the screen, it seems that this model has 3 components, but when you use the select tool and scroll the slider one by one, you will see that this is the first one. The head is the first one. Then the second one is not that visible. See, the fourth one is the duck. And then you have several that's not visible. And the last one is the base. So it seemingly has 3 components, but then it has several invisible components. In order to find out what happened to the invisible component, you can go to the export folder, and just from the file size, you can see that these 3 are the main components, whereas the rest seems to be very small, and actually they are a sort of defects. I selected all the files, click copy, and then go to Luban folder, click on the Luban folder and press keyboard shortcut Ctrl V, paste. It will paste all the files into a batch, and the batch is displayed on the window. So this is one of the small component. I can use up and down, left and right keys to browse the batch of files. So if I press down, that's the next one. Again, a very small one. Next one. So this is part 4. Part 4 is the duck. Part 5 is a small one. Part 6, then we have the base. And then we have, okay, this is the first one. That's the head. So this tool let you see all the files, all the individual files in one window. And it also displays the components in the word coordinate and put them all together in the word coordinate. Okay. You can do Ctrl C, Ctrl V, and this is in a batch, and then do batch assemble. It will assemble all the components in one window as well, but it will not show you the single color. It will not show you the single color display as in mesh separate function. So this display, in this display, each component is shown in one color, but in the assembled display, each component is shown as a color map. Blue is a low Z value, red is high Z value. So that gives you a better display, in my opinion. Lastly, I want to show you an example that I used in the picture model STL Phoenix. Okay, the Phoenix model is given to me by a friend, and if I do mesh separate, save to the export folder, you'll see that when he modeled the very complex shape, he has done it in several parts. The first part is the main body, then the hair, then the flame, then a ribbon, then the base. These are the components that he has embedded in the STL. Without the separate function, it is unclear how many components are there. If an STL has disconnected components, and when you use mesh cut, modular cut to cut the STL, what Luban does is first call an embedded separate function to separate all the components and then do cutting. Here is an example. I'm going to set the model to 200 in Z, and these are the printer size. Presumably, it will just do one cut. Click Cut and save it to the desktop. As the height of the model is not very big, it should only apply one cut, but you see several components generated. The hair, the flame, the base, and the ribbon, they are generated because of the embedded, the inner separate function that precedes the cutting function. Only after separate does Luban actually call the proceed function. Does Luban actually call the cutting function to cut it? So only the main body is actually cut. The other ones are separated. That is all for this video. Thank you for your attention. I hope you like the new display of the mesh separate function. Thank you.